Alright, we're going to work on 6.1b. These questions are going to be the ones that's in your handout that I emailed you, the PDF. So this is 6.1b. And I don't want to start with the first couple of questions here. I want to skip those for a moment and go to number 4. So what we're going to do here is we're going to graph this. It says it's inequality. And wherever the graph is above the x-axis will be our answer because it's a greater than symbol. If it's a less than symbol, we look for where the graph is below the x-axis. This is very familiar with the other chapters where we did polynomial inequalities. So first off, you got to find your vertical asymptote, your horizontal asymptote, and your x-intercepts. So your vertical asymptote would be saying the bottom equal to 0. So x equals -1. So I'm going to graph that on here. -1. So there's my vertical asymptote. Okay. Your horizontal asymptote, well, that's where you check out your degrees. And that would be 1/1 because the degrees are equal. So you take the coefficients and you divide them, the front coefficients. So 1. So y equals 1. There's your horizontal asymptote. X-intercept, you take the top, set equal to 0. So you have an x-intercept at 1, 0. Okay, now if you use your graphing calculator, you can fill the rest of that in. I'll use my fancy Casio here. X minus 1 on top, x plus 1 on the bottom. And there's she is. So it flows up like this, and then flows around like this. Okay? Now you need to know, where is the graph greater than 0? Where is this graph bigger than 0? Where is it above the x-axis? Well, if you look at this is below the x-axis. So you don't even want that part, right? That's below. So we don't want that. So this part right here, we do not want. What we do want is above the x-axis. This is above the x-axis, right? So we want all of this stuff right here. So from negative infinity, right? From negative infinity all the way to -1. Then, we always put a parentheses around an asymptote, no matter what the inequality symbol says. Okay, we're going to skip from -1 to, what was that number? Oh yeah, it was 1. So we're going to skip from -1 to 1. We're going to start back up at 1 again. Now you can have a bracket on an x-intercept, right? But in this case we don't because it's just a greater than symbol, so don't worry about that. And it goes off to infinity, right? Because all of this is above the x-axis. So we want this forever. Okay, and it goes forever, and that graph will tend to the horizontal asymptote forever and ever and ever. It won't dip back down because we already found one intercept, and that's the only one that's available for the x-intercept. So there you go for your. So there's number 4. That'd be your answer in interval notation. Let's check out number 5. Let's check out number 5. It's the same idea. We've got it in a. Everything's on the left, less than or equal to 0. So when I say less than, we're looking where the graph is below the x-axis. So we want a vertical asymptote first. So vertical asymptote, you set the bottom equal to 0, x equals -1. The horizontal asymptote, degree of the bottom is bigger than the top. That means y equals 0. Okay, your x-intercept, oh, that's horrible, sorry. X-intercepts, you can't set the bottom or the top equal to 0. So there, none. So now we can go to our graphing calculator. We can type this in. Let's see, 3 over x plus 1. You don't have to use your graphing calculator every time. You can pick points if you wanted to. It's just as easy for me just to do it like this. So we'll see that it comes in here. So, did I graph that right? Yep, x over 3 plus 1. Like so. We want to know where the graph is below the x-axis, below the x-axis. Well, below the x-axis would be all of this, right? That's below the x-axis. So we want everything all the way to -1, right? All the way to -1. So all the way negative infinity to -1. Remember I said you always parentheses in an asymptote because you cannot plug -1 in. Even though there's an equal sign here, we do not use a bracket, we use a parentheses. Because if you were to put a bracket, that means include, and you can't include -1 because it would break the whole function. Well, now I've done the easy ones. Now we're into these kind of problems where either there's something on both sides. Okay, so there's something on both sides. So let's try the one where there's something on both sides, like number 2. So we'll try number 2 here. So basically, I'm going to make this look like the ones we just did. I'm going to move everything over. So if I move this, it was negative. If I move it to the other side, it'd be positive. Excuse me. So if I move it over, it's not negative, it's now positive. Well, if you had the same denominator, all you do is add the numerators. So -5 plus 2x over x plus 3 is greater than 0. Some people don't like to look at it where the x is over here, so I'm going to rewrite it as 2x minus 5 over x plus 3. It's just a matter of choice. I like it like that better, though. Vertical asymptote. If I was going to graph this, what would be my vertical asymptote? Check the bottom equal to 0 of x equals -3. Okay, there's -3. Horizontal asymptote. Degrees are the same. They're both 1. So you take your coefficient divided by coefficient, and you get 2. Y equals 2. Okay, your x-intercepts. Remember, you take the top, set it equal to 0. 2x equals 5, divided by 2. X equals 5 halves. 5 halves is 2.5. Right there. Okay. Now I can graph this, but it has to go through right there, right? Let me graph this, make sure this is right. So it's yep. There's that part. Oh, I don't have a very good window. Go back to a standard window. There it is. Okay, so now we want where the graph is greater than 0, where the graph is positive. Well, where it's positive, this whole piece over here is positive. So we need to include that in our interval notation. So negative infinity all the way to -3. Always parentheses in an asymptote. Now, above the x-axis, or from here over, is above the x-axis. Now, if you hadn't found the x-intercepts, you wouldn't know what the answer was there. So you're going to start back up, parentheses, because it's just a greater than symbol, 5 halves, comma, we'll go out to infinity. That's how you get your answer in interval notation. All right. Let's see. Let's try this one. It's got the same denominator. It's 3. It's question 3. Move my x over. -5 minus x over x squared minus 1. See, we've got the same denominator, so I'm just going to move it over and make it a -x. Less than 0. Well, vertical asymptote. Looks like I'm going to have 2 here. Because you take x squared minus 1 and set it equal to 0. Since there's no middle term, no middle x here, you don't have to worry about factoring the quadratic formula. You just move the 1 over. And we take a square root. And remember what happens when you take a square root? Plus minus. And the square root of 1 is 1. So we've got 2 x-intercepts. I'm sorry, vertical asymptotes. 2 vertical asymptotes. So, at 1 and -1. one. All right. Horizontal asymptote. Degree of the top is bigger than the bottom. Degree of the top is bigger. I'm sorry. Degree of the bottom of 2 is bigger than the degree of the top 1. So I got a bigger bottom. So that's y equals 0. All right. What's left? X-intercept. Well, I take my numerator, set it equals 0. Make it -5. -5. Okay, so let's look at what this looks like. Menu here, delete. -5 minus x over x squared minus 1. Looks like the graph comes in here and shoots down. In between, it's up here. And then this one just follows through here. So look, you wouldn't have noticed this on the graph, but if you know that there's an x-intercept right here, you knew that the graph was above here. So now we're asking ourselves, where is the graph less than 0? Below the x-axis. Below the x-axis. Well, looks like all this stuff here is below the x-axis. They're -5, right? So everything here, all the way to -1. So from -5 to -1, and it's just a less than symbol, so parentheses on everything. This is above the x-axis, so I don't want it. Now here's below the x-axis. I want all of this little guy here. Well, he goes from 1 all the way to infinity because there's no other x-intercepts. So he's gonna hug the y asymptote, the horizontal asymptote, but he's never going to cross the y-axis. I'm sorry, the x-axis. He'll never cross the axis. So from 1 to infinity. Right? Number 3. Oh no! Now look, we're down to these other 2 guys. Oh wait, here's one. Here's one. Oh, I've got 2 more left that has the same denominator. All right. So move the 4x over. -1 minus 4x over x plus 4, less than or equal to 0. So vertical asymptote. Do you see -4 gives you 0 on the bottom? That's a vertical asymptote, -4. All right, so we got that -4. Our horizontal asymptote. Well, degrees are the same, so we take -4 divided by 1. -4. Y equals -4. -4 is here. X-intercepts. So you set your top equal to 0. I get -1/4. Okay, that's interesting. Oh, wrong side, wrong side. Imagine that's not there. Haha, fix that. So, -1/4. Okay, now I want to graph it. I'm pretty sure it's going to come down through here. It's got to, because it's got to hit the x-intercept. It'll probably be down over here too, but I'm just going to make sure. Use the graphing calculator. We'll delete this. Type this in. So it's -1 minus 4x over x plus 4. Draw that. Yep, just like I said. So it's got to come in here. Oh, shoot, I missed it. That's at -1/4, right? So and then this side over here is in here. Now you're wanting less than or equal to 0. Less than or equal to 0. That's below the x-axis. This whole bugger right here is below the x-axis, right? So he's from -infinity to -4. Now you'd think you'd use a bracket here, but you do not bracket in an asymptote. Parentheses. No matter what this says, you always bracket parentheses in an asymptote. Below the x-axis again. Well, all this booger here. He starts at -1/4, and he's going to go forever underneath the x-axis. So now wait, that's an x-intercept. You can bracket that in. You're going to have to bracket that guy because you can include -1/4. So I'll bracket this guy. I almost screwed up there, didn't I? So you bracket in the 1/4, -1/4. Then you go to infinity. Sweet. Oh, one more with the same denominator. Let's move the x over. 5 minus x over x squared minus 4x plus 3. Less than or greater than or equal to 0. Vertical asymptotes, you set the bottom equal to 0. That would factor. That would factor. So we're going to take that, let's see, that would be x minus 1, x minus 3. So x equals 1, x equals 3. Those are two asymptotes. 1, 3. Okay, horizontal. Degrees bigger on the bottom. Y equals 0. And your x-intercept is at 5. Right? 5 is what gives you a 0 on the top. If you don't see it, you say top equals 0. Okay, so now let's look at what the graph is. So we got 5 minus x squared minus 4x plus 3. It's interesting. Follows this guy, shoots up. Got a little u on the bottom. Follows down this way and goes through the x-intercept and then follows the horizontal asymptote. So where is this bigger than 0? All this piece through here, negative infinity to 1. We're always going to parentheses a asymptote. Then from 3 all the way down to 5. And we're going to bracket the 5. See, it has an equal to's on it. We're going to bracket this guy. Since he's an intercept, we bracket him in. All right, almost done. Looks like we got number 6 here left. Question, and this is number 6 and number 1. Here's number 1 somewhere. 1 and number 6. These don't have the same denominators. Let's do number 1. So I'm going to move this guy over. I should have wrote that. Okay, negative 4x minus 16 over x minus 5 is less than 0. Well, I can't put these things together because they don't have the same denominators. This has a 1 underneath of it. I want an x minus 5 underneath this. So it is legal for me to just say x minus 5 over x minus 5. I'm going to multiply this fraction over here by x minus 5 over x minus 5. And that's just a fancy 1. And it's legal because anything times 1 is itself. Okay, so this is 1, right? Anything divided by itself is 1. So I multiply this out. You get negative 4x squared plus 20x over x minus 5 minus 16 over x minus 5 less than 0. Well, you've got the same denominators now, so you just subtract this off. You just put the negative 16 over here. Okay, so the vertical asymptote is 5. Right. And your horizontal asymptote, the top is bigger by 1, which means you have to use long division to divide that out. You're going to have a slant asymptote, it looks like. You have to divide this out with a long division to find your slant, oblique asymptote. So turn an x into a negative 4x squared. You need a negative 4x. Multiply that up. You get negative 4x squared plus 20x. Well, that cancels. You're left with negative 16. Well, you can't turn x into 16. So that's it. Y equals negative 4x. That's how you find slant asymptote. 4x. That says an intercept here at 0. And you go up 4 over 1. There's the slant. So I like to extend these on up here. I didn't do a very good job leaving myself enough room. But this is going to extend up here. We need to probably have some of that stuff. And then our x-intercepts, you set the top equal to 0. So let's take our top negative 4x squared plus 20x minus 16 equals 0. So if we set that equal to 0, everything's divisible by 4 here. I'm going to divide everything by negative 4. So that's x squared. That'd be negative 5x. And that'd be a positive 4. You can use the quadratic formula on this too if you wanted to. But this tells me an x-intercepts of, oops, they're both negative, 4 and 1. So x equals 4, x equals 1. My x-intercepts, 4 and 1. So let's check out our graph. This guy right here. It's interesting. So, oh shoot. I did a positive 4x there. My horizontal asymptote is a negative 4x. I made a mistake. Oh no. Oh no. Let me redraw my graph here. My vertical asymptote was at 5. Okay. I made a mistake. My horizontal asymptote was negative 4x, and I can see that now, negative 4x. I'll show you the graph of it so you can negative 4x. You can go ahead and graph that horizontal in there with it if you don't know how to graph that. Watch the red graph here. See, there's negative 4x. I didn't do that right. I did a positive 4x. Shoot. Back one. So here's my graph. It goes through at 1, and then comes back through at 4. Now if I zoom out here, you'll see where the rest of that is. Move down here. See the bottom piece eventually. There it is, way down there at the bottom. This. Okay. So where is this thing? See, it's asking less than 0. It is less than 0. Let me look at the graph. Yep. So this is less than 0 from 1 to 4. Right. 1 to 4. So parentheses 1 to 4. And we're using parentheses because it's just an equals, it's just a less than symbol. Then from 5 to infinity, it's less than 0. It's going to be below, it's going to be trapped down here. So it's always below the x-axis there. Sorry for the confusion. And the last question, without the same denominators, is this guy. I'll move this guy over. Okay, so move this guy over. He's at positive 5 now. Well, now I have two different denominators. So what I do then is I multiply this one by x minus 1 divided by x minus 1. That's a fancy looking one. Guess what I multiply over here by? X minus 2. Okay, so we wind up with negative 5x plus 10 over x minus 2 times x minus 1. Don't multiply that out because you just factor it back out here in a second, so don't worry with multiplying that out. Multiply the top here, 5x plus 5 over x minus 2 times x minus 1. I forgot to put my less than or equal 0 here. Now this stuff just goes together. Negative 5 plus 5 is nothing, And 10 plus 5 is 15. Your vertical asymptotes. So this is why you don't need to multiply this out. X equals 2, X equals 1. You just set the bottom equal to 0. Your horizontal asymptotes, well, the degree of the bottom is 2, because there's 2 factors, right? Degree of the top is 0. Y equals 0. Your x-intercepts, you can't set the top equal to 0. It's always 15. So x equals 2, x equals 1. Horizontal asymptote at y equals 0. We can use our graphing calculator to get this guy. Delete both of my little graphs off here. So type in 15 over parentheses x minus 2, x minus 1. Draw. Oh, I got my stupid window. Set back to a standard window. So it looks like this does this number here on the outside. So I wonder what happens in this one. I wonder what happens in there. Well, if I look at my table, I can see what would be a number between 1 and 2, like 1.5. I get negative 60. That means the graph is way down here at negative 60. This means the graph is way down here. So where is it less than or equal to 0? In between here, from 1 to 2. And there's 6.1b.